Now, we played one round yesterday, correct? You remember that wonderful round? That was a wonderful day. Remember that? But there were some problems with our conclusions. There were some problems because when we performed the experiment on Thursday, right? We found that 1 gram of the sodium bicarbonate, or sodium carbonate, Na2CO3, required how many milliliters of this stuff? 46. 46 milliliters. That would be equal amounts of what? Equal what? Moles. Equal moles of the two. But we did that calculation before. Remember that? We did the calculation before. We can do it again right now if we just trust ourselves.
It was equal to the ratio of moles.
It was equal to the ratio of moles. 1 mole of sodium carbonate to every 2 moles of acetic acid, HC2H3O2. This was the calculation that we determined before. Agreed?
Yes.
Remember we did like a couple weeks worth of calculating to make sure that that was the mass of sodium carbonate, and that's the volume of acetic acid, right? Now, yesterday, I said, okay, let's say I have 1 gram of this and 100 milliliters of HC2H3O2. Which should be in excess?
That. H2O2.
Right, and then the solution should be what color?
Yellow.
Yellow. But remember in the end we had the number of moles and we said it was purple, right?
Yeah.
We made a mistake yesterday. We made a mistake yesterday in our calculations.
Is it just which one you more of, not which one you
The mistake, no. The mistake was this. Remember we were saying 0.083 molar? Remember we were saying 0.083 molar? It's not actually 0.083 mole.
It's 0.83.
It's 0.83 mole. Okay? So that was a mistake we made yesterday. The concentration of the vinegar is 0.83 molar and not 0.083.
Percent?
No, 0.83 molar. Molar. Now what does molar mean?
For every liter.
There's
Mole
what?
per every liter.
There's for every.
1 mole per every
There's not 1 mole, but there's how many?
moles per every liter.
There's 0.83, right? That's what that means. That's how many moles are per liter.
Using the incorrect value, we got 0.0083.
Yes.
It was supposed to be
0.08. All right.
It would have been.
So, yes, it would have been yellow. Okay. So, right? Now, I'm going to give you a new reaction, new equation, new reaction. Okay? It's going to be a generic one so that we can practice a little bit. All right? But it's basically the same game. This game I'm going to call green or
Red?
Yellow.
chartreuse. I don't know if that's how you spell chartreuse. Can everybody say it? Green or chartreuse. Ding, 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 ding. Okay? I don't know. Now, in this game, if there's excess A, it's green. If there's excess B, it's chartreuse. And here's the reaction. 2A plus 3B goes to form, let's see, A2B3. All right? There's our chemical reaction. Okay? A, here it is right here, I'm going to draw it. 0.7 molar. A is a solution. That's 0.7 molar. Okay? Does everybody see A? I drew it. Did you guys see A? Oh, good.
A what?
I drew it. Right? There it is. 0.7 molar. And here's B.
How many molars do you have?
B is 0.3 molar. Whoops, that's not a good one. There's B, 0.3 molar. What does 0.3 molar mean? What is 0.3 molar? Anybody? What's 0.3 molar mean?
0.3 moles per liter.
That's right, 0.3 moles per liter.
Isn't that a tiny amount?
Not necessarily.
It depends on what the element is, because moles can be bigger or smaller.
All right, now, here's the question. If I have 50 milliliters of A, how many milliliters of B do I need? Well, no, we're gonna play green or chartreuse. If I have 50 milliliters of A and 80 milliliters of B, is the color, and then this is where you say it, is the color ding 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 ding. Very good. All right, what do you think? What do you think?
So 50, it's chartreuse.
Really? How do you know?
Wait, because it's 2 for, well, you need 2 for every 3, and so that means that to be equal, you have to be 75, but it's over, and it's 80.
Even though these concentrations aren't the same?
Oh, I thought we were just doing.
Oh no, we are doing this. This is the stoichiometry, but these are the concentrations that are provided.
Oh, okay.
Is that right? I mean, I don't know. You might be right. I'm just wondering if you took that into account too.
I
These
don't
concentrations. Okay. So
But that's-
how can we solve a green or chartreuse problem like this?
I know.
How much? Set it up. What are we going to look for on the right here?
An equal sign.
An equal sign. Very good. An equal sign. And as we breathe out, we better be thinking about what we're looking for, because what are we looking for? How?
Chemical A or chemical B?
Okay. So moles of A, and then moles of B, and then we can use the stoichiometry to see if who we have more of. Does that make sense?
Yeah.
Okay. So what do we start with? Moles of A or moles of B?
Don't we just guess?
We can choose.
A.
Moles of A. All right. Moles of A. Okay. How many moles of A? How are we going to decide? What information in the problem tells us something about moles
50
of A?
milliliters.
All right. Is it okay if I put 0.05 liters of A?
Yes.
Is that all right? That's the same
But
as
then
50
you need to
milliliters.
divide it by 0.07.
All right. 0.07. What needs to go down here?
No, it has to be liters.
Liters down here or moles down here?
Liters.
All right. 0.7 liters of A? Is that what this 0.7 means?
No, that's a milliliter, so it has to put 0.007 milliliters.
No. What does this 0.7 mean?
That's the concentration.
That's the number of moles for every
Liter.
liter. Right?
So you need,
Down
you
there
need,
it goes 0. No, then it's 1 liter.
yeah, 1
1 liter of A on the
1 liter.
bottom. That's right. 1 liter of A here, and then up here goes
0.7 moles.
0.7 moles of A for every 1 liter. All right. Now we need a calculator. .05 times 0.7. 0.035.
Yeah, that's what I
Is that what you guys got?
Yeah.
All right. Now what's the other thing we have to do?
Divided by what?
I got it.
We have to do the B now, right? Equal sign. What goes to the right?
So what do we figure out? Is it 0.035?
That's how many moles of A are in 50 milliliters of this 0.7 molar stuff. Okay? Tommy Joe. You ready?
Wait.
Equal sign moles of.
No, that's incorrect.
Is it?
No, it's not. Because you would.
0.05 times 0.75.
Oh, yeah.
0.7.
Because 0.0.
You forgot about the .03.
Should be right.
Yeah, you
Think
forgot
so,
about
right?
the 0.03.
Did you do it in your calculator? Uh-oh. Try it again. Maybe you are wrong. Maybe it's 0.35.
What?
Oh, 0.05 times 0.7 can't be 0.35.
0.0.
What is it? Times
Times
0.7.
0.7
I got the same thing.
equals.
Wait, times.
Oh, 0, 0.
All right, 0.035. 0.035. Excellent. Okay, now moles of B. What goes to the left here on moles of B?
80 milliliters.
Or
0.08.
8 liters of the B, correct?
And then it's just 1 liter.
For every 1 liter of B, we get what?
And then 0.3 on the top.
0.3 moles of B.
0.
And then
0.8 liters times 0.0.
0.024.
Yeah, that's about right.
wait, what?
0.08 times 0.3.
Well, in order for it to be searching, he has to wait.
Times what?
0.024.
To what?
All right.
No,
So,
it's 2
2 A's.
Wait,
For every 2 A's, I need 3 B's.
Oh, yeah.
0.08
And there's more
times
A's.
It's 0.
Wait, saying is, you need less A's to get to turn it green than you need B's.
And we already have more
Or
A's.
you have more A's. So there's no chance.
So the answer is
Green.
green. Green.
chartreuse.
How much?
It was.
How many moles of B would I need?
0.0525. To make
So you took 0.35 and did what with it?
By 2, and then times it
Okay. So this divided by 2 times 3 gave us a value of how much?
0.0525.
0.052.
That'll equal it. So if you wanted it, it'd have to be 0.0526.
Yes, or 5.1 or something.
One of anything.
Very good. Congratulations, guys. You just played.
Green or chartreuse.
Good job. That's good for today, gentle people. So, what we're introducing
One
here.
more minute.
Oh, well, then I'll give you 1 more minute for free. What we're introducing here are what we call what?
Titration.
Very good.
Titrations.
Titrations. Yes. Do you know a song about titrations?
Nope.
No? It sounded like it. Can somebody please sing us a song about titrations? All right. A titration is an experiment where you mix a couple of things. You have to know their stoichiometry, right? You have to know the stoichiometry. You have to know the concentration of one. And the other one might be an unknown, but you can figure it out by the indicator that's there. Correct? So, tomorrow is Wednesday. I have something I have to do in the morning, so no chemistry Wednesday.
No.
You mean tomorrow?
No chemistry tomorrow.
Why?
However, on the next day,
Why?
I'll bring some titration setups. Okay? What you're going to do is you're going to use the sodium carbonate and the acetic acid, and you're going to find out. I'm going to have some acetic acid that I'm not going to tell you the concentration of. All right, and you're going to try to find out the concentration
Does that mean that it
by
could be
doing
like
titration.
really high and it could be deadly?
It will be deadly, that's for sure. So, those of weak constitutions need not apply, right? Okay, we'll see you guys on Thursday.
Yep.